Right. So let's start with Express.js. So Express.js is a Node library, and it's basically a library that will help you to handle requests, incoming requests to a server, right? So I would go as far as to say, think about Express.js as a web server, right? It is not actual web server, but think about it as a web server because it basically handles all incoming requests, and you can do pretty much whatever you want with those requests. So when they arrive, you can set different rules of how to handle them. You can refuse them. You can accept them and do some work and so on. So yeah, so that's Express.js. Let's just continue with it. So officially, it is a fast, unopinionated, minimalist web framework for Node.js. So yeah, pretty much what I said. It is kind of like a web server, but it's more of a kind of layer up. It's like a web framework to handle whatever you need to do around your requests. So if you are familiar with web servers, and actually tell me now if somebody is not familiar what web server is. You.
I wouldn't mind kind of a reminder of what it is.
Okay. So yeah. So okay, let's start with it actually because it's important that you understand it. So
is AWS a web server? You'd say.
Web server can be many things. It doesn't have to be AWS.
But is it what it is? So it's like a server on the cloud.
It's a server in the it's funny. It's a server in the cloud. It can be server in your bedroom. It can be anything really. It can be on your local as well. It doesn't have to be in the cloud. It doesn't have to be on the internet. It can be just your local.
Okay. So in our exercise, it's like the local 3,000, for example. Yeah. Okay, got it.
Yeah. So let me just create you a new diagram in here. Yeah, sure. Right. So when we talk about web servers, imagine that we have a client. So this will be our client, and then we have our server. Let's say it's a Node.js server. Right. So by default, what you want to do is you want to make a request from you want to make a request from client to the server, right? So that's what you want to do. Now, normally, what you would do is, what the architecture would look like is that there would be something in the middle, and that thing, there would be many pieces in the middle, but the most important, I would say, in the middle would be the web server. So let's just put it in there. So this is your web server. So the request doesn't go straight there, but it goes first here. Oh, I don't know what happened there. Goes here and then it goes here, right? And this is bidirectional, so it kind of goes this. Oh, God. It kind of goes here. Oh, there you go. Right. Let's just leave. Okay. Yeah. So this is the, let's say, very simplified architecture of what's going on when you make a request. When you make a request, you basically saying, I want to contact this server, which would be this thing, right? So you would have something like this, and I'm simplifying everything just for a reason, right? So, but let's say this is our server. So I want to make a request to a server to give me some kind of website. Okay. Now in that server, we will have the web server, and we will have the actual application, which is a Node.js. So let's just change this to application. Now, when you make a request, it will go to web server, and the web server will decide based on some kind of rules to what application the request should be passed on to, or if there is anything else to do with that request. Now, what can you do with a request on a web server? You can, for example, you can do a redirection. So you can say, let's say that a new request for www.google.com comes into the web server, and the web server knows that website is actually not here, it's somewhere else. It will redirect you to somewhere else. So it can issue redirection straight away. It doesn't actually go to your application at all. It can just redirect you straight away. The same way, if you're requesting something that doesn't exist. So for example, a web server could serve an application, right? The other thing that it could serve would be just some files, right? So it can just do a static files. So if you request some file on the server and the file doesn't actually exist on the server, the web server itself will return you 404, and it will tell you, this file doesn't exist in here. So it can do many things, web server. It can also handle encryption, so HTTPS and other things. So web server is the application that will receive all the requests, and then it will distribute them down to where they need to be distribute them, or it will handle them. Web server is not a kind of customized application. It's an application in a sense where you give it a config, it will read the config, and it will behave depending on the config, but you cannot actually put any logic in it. And this is important to know, because if you think, well, I could actually, maybe when I received a post, I could save something in a database in here. You can't actually do that, because the web server, because it doesn't have any logic, cannot actually unpack the request. It's also on different layer in the networking, which we can talk about later. But basically, what happens is you receive the request. It will see the request URL, method, and the headers, and it will decide based on these things where it should go, or what you do with it. If you send a post request that has some kind of body, the web server will not be able to read that body and do something with it, or decide based on what you actually send, what kind of content you actually send. That is done only in the application itself, not anywhere else. So if I just put database in here, the application can go to database, but web server cannot go to database. The web server needs to go through some application to actually get to the database. Is that somehow clear?
Yes, thank you.
Yeah. Do you know what request and response are in our communication over HTTP? In our web communication.
You mean the get?
Well, it doesn't necessarily matter what method, but do you know, like, generally speaking, what happens when you make a request or when you get a response?
Sorry, I'm not sure about the question. Sorry.
So when you request something from the server, what is the request? What it actually is. So this will be one thing that you would be asked on interviews when you actually go and apply for a job. They would ask you, describe to me what happens when you type in an address. So if I go here and I type in google.com and I press enter, what actually happens going, like, from that point when I press enter until this page is loaded, what actually happens?
I'm not sure, actually.
Cool. So let's talk about it a little bit. So what happens is, so when you type in the address, the client, which is your computer, will make a HTTP request to a server. HTTP stands for hypertext transport protocol. Sorry. And it basically is the protocol that we are using to request stuff over the web. So the client initiates a request to the server, and the server will handle the request, and it will initiate a response to the client. Now, that's quite simplified, but let's just go with that for now. So when we say request and response, what it does, so the client will create a request. Let's create a request in here. Right. So this is our request, and the request has a couple of parts. One part is the method. So you know that was your get, post, put, delete, and other methods. The other part would be your headers. I think you are familiar with headers already as well. So that's basically, let's say, a metadata that you're adding to a request. So the server knows how to handle your request. Let's say you can put authentication in there. You can put a content, accepted content for that request, and so on. And then you will have your URL. Well, actually, so let's put URL in there. So you will have your URL, and you will have your data as well. So this is the data or / body of the request. So this is how the request that you make to the server looks like. Now, some of you might argue that URL is not actually there in the request, which would be partially correct, because URL is included in the header. So in the headers, you will have host header, which basically includes the URL of what you're requesting, right? So the URL is really part of the headers, but for the sake of kind of understanding and making this clear, I like to include it as a part of the request like this, because it's kind of clear that you're requesting something with URL, right? So you're requesting this. So this is your request. So this is what the server, this is what the client sends over to the server, okay? And this is up to you to construct this. Once the server receives it, so that's the web server receives it, it will see the method, headers, and the URL, and it will decide what to do with this request based on that. It will know about the body, but the only thing that it will know about the body is what content type it is in and how big it is. Because for the web server, it's just basically a long string of something, right? It's serialized something. It's called stream, but we don't have to worry about it for now. So it will know the size of it, and it will know from the headers, it will know what type the data is. And then based on that, it will decide where to go. So if, for example, if you say, I want to, so let's go back to this example. When you request google.com, what it actually does, the browser, so this is not your code, right? The browser, when you put URL in the address bar, the browser itself, I don't know if you can read this actually, now that I think about it. The browser will make a GET request to that URL, right? So let me just make it slightly smaller. That's probably.
It's fine, I can see.
Is it okay like this?
Yeah.
Yeah. Okay.
I don't know about the others, but I can see.
Cool. So it's just this zoom is behaving really strangely. I can't really zoom easily to some good. There it is. So, I'll do something. Right. So you make a GET request, right? So let's just write it out in here. So you make a GET request to HTTPS google.com. So when you write something in here, it's always a GET request, and it will go to that URL that you typed in. From then, the browser will know which server to go to. That's because there is something called DNS, which is kind of name translation. So it will translate this name into an IP. Let's not worry about it for now. That's kind of we can learn about it a little bit later. It's a little bit more advanced. So this URL is going to be converted into an IP address, which is basically network address, and it will go to that server. It will arrive to this web server, and this web server will have some kind of configuration. And inside of the configuration, it will say any request to https://google.com, so any request to this domain, I want to use this application, right? So I want this request to be handled by this application. So it will, because it matched, so we call it matches, so because it matched, it will take the whole request and it will pass it on to the application. The application then will somehow process the request. There are unlimited ways that you can process requests. It can be a Node.js, it can be a PHP, it can be absolutely anything, right? In our case, one more thing that the web server will do is, because you didn't put anything in the address, in the actual like a search part of the address, what we call, because we didn't put anything in here in the actual URL in the path, it will look for the default path. And in web server, you can define what the default path is. That's why you see everywhere index HTML, index PHP, index JS and stuff, because, well, not so much index JS, because that's what is usual kind of as a default enter point, basically. You can have anything you want if you configure it in your web server. So for example, in your application, as we have, as I have in here, I have index.js. If I would create index.html, then the web server would serve this index.html first, because it would look for, if you don't put anything in the URL in the path, it would look for this file, index.html. That's just the default for everything. I could also rename this to root.html, for example. Right? I can rename this to root.html, but then it wouldn't work. What I would have to do is I would go to web server, and for my configuration of that domain, I would say the root file or the index file for this domain is root.html rather than index.html. So you can configure the web server to basically handle your own kind of architecture and your own kind of the way that you set up your project. So you do that in the web server. So the web server, the request comes in here. It will find that https://google.com lives on this server, and it will come into this application. This application will then do something, and it will issue a response. Right? So it will create a response object. The response object, let's create it in here. So actually, let's copy this. The response object has status, it has headers, and it has the data. So this is our response, right? This is all very simplified, but that's all what you need to know right now. The status, what do you think it is? Ricardo, what do you think the status is?
Is that the 200, 400, 500?
Yeah, exactly. So that's your HTTP status. So that's your status code to kind of identify what actually happened with the request, if it was successful or not. So that is coming from the application. The application is to decide, was this successful request or wasn't it? Was it not? In the headers, you will have your response headers. So again, identifying what the content type is or what the cache rules are and so on. So this is now metadata for the client to basically process the response, to know what to do with that response. And then you will get your data or body. Not always, obviously, with GET request, well, you will still have data body because you're serving files and or some kind of data, but you could have empty body requests responses as well. Again, with request for GET, you wouldn't be sending any data body. It would be just these three. So the application will process the google.com, which in this case means that it will send you this, right? So if you do inspect on a page, sorry, not inspect, view the page source. So this is the source code of google.com page, right? This is the default source basically. So this is the kind of static source. So it will, that application in here, when you send the request in, that application will generate this somehow. It will generate this. It will package it up into a response. So what you see in here will be the data. It will create a status of 200 because it was successful. It will create some kind of headers. Content type in this case will be HTML because you're sending back HTML. And it will send it back to the client. Okay. It goes through the web server as well, but in this case, it's mainly just forwarding. You can set up some rules for outgoing responses as well, but mainly it's just forwarding of the responses. So that's what happens then. Now, once it arrives to the client, in this case, when you're actually handling the loading of this page, the client will expect HTML. It will take that HTML and it will literally just render the page. Now, as you can see, there is image in here. There is some kind of styles, right? So this is not just default HTML. This is some kind of styles and all sorts of other stuff. Wow, this is very interesting. So to do that, obviously, you need JavaScript, you need CSS, you need images, and so on. Everything that you see on the page, what I just said, the CSS, JavaScript, and images, they are all external assets. They are all kind of things that you need to load as well, right? So when you load this HTML page, it will examine the page and it will collect any kind of external links that it needs to load. And once it collects them, it will make those requests again. So if you can imagine it, you will make a request from client to the web server. The web server will issue a response, and on the back of the response, the client will collect all the links that needs to be loaded still in that HTML file, and it will make X amount of requests again to the web server, and it will say, give me, so this is the first one, and then it will say get google.com styles CSS and get google.com main image JPEG, for example, and so on and so on and so on. So it will make many requests. Let's just have a look at the page now. So if I go into inspect mode and we look at the network tab, so here you can see everything that's happening in the network. If I reload the page, you see all these are requests that are being made to web servers, right? To any kind of servers. They don't necessarily have to be all on the same domain. Like if you look at, I don't know if you can see, but as I'm hovering it, this one goes to www.google.com. This one goes to gstatic.com. This one goes to id.google.com. And there was one that goes somewhere. This one goes to Poach Global Font Assets, and so on and so on. So it doesn't have to be always the same web server. So it will just collect all the links on the page and it will make all these requests. So you can see how many requests, like the browser is doing a lot of work, right? Like you can see how many requests. I don't know if there is some count. Yeah, 39 requests just to load this page. Okay, and one of them is blocked for some reason. So that happens then. The client makes instantly 39 requests to other web servers. Some of them go to this one, some of them to the others, and they get processed exactly the same way. For example, in the image, so if you look at this image and the styles as well, those are just files, those are just static files. So it will come to the web server, and the web server will have a rule. It will say, okay, this is coming to the google.com, so I know how to handle that, and the extension of this request, so this basically at the end of this request, which is the extension, the file extension, it will have some kind of rule. It will say if there is CSS or JPEG or JavaScript or anything else that could be a file, then serve it as a static file. So basically, what it is saying is, and here is the folder. What it's saying is, look at the folder where we know that we have the static files. Find these files, and if they are there, issue a response. So now the web server is issuing a response. Issue a response with status 200, correct headers, content type, and so on, and the file that you actually found. If it doesn't find the file, it will still issue a response, but the status will be 404, and different headers will be, maybe just text or something, and the body will be empty. If it finds the file, but the permissions, for example, are not set up correctly on the server, then it would issue a response of 403, you don't have access to that, and headers and empty body. So the web server can do stuff as well, but only by analyzing the URL or the headers of the request, not the actual content of the request. So, for example, if we would then, once the page is loaded, we would make a post request. So let's say that we are actually submitting the search, right? So we would say post google.com, and then there will be search, and we would have something like query equals blah, right? Something like this, let's say. Or the query would be in the body, it doesn't matter. So you would make a post request to the server. Now the post request would arrive to the web server. The web server would say, okay, I have a request for google.com. At this point, the web server doesn't really care if it's get or post. It can, but it doesn't. In our example, it doesn't really care. So it will look at the method. It will say, I don't care about that. Headers URL. I know the URL. Let's move it forward. It would pass the request to the application, and in the application there would be a rule. Okay, on any incoming request, if it's a post, handle it somehow. And in this case, we will have the query, so the application will know, okay, let's go to the database and check all the results for this query, and then again, collect all the data that I need, package it up as a body, and send it back to the client. So create this header status, correct status, and send it back to the client. So the web server is kind of, I don't want to use the word, but it's kind of, let's say, a proxy, or is a, let's do it differently, is a gate between the client and the actual applications. The important thing to understand is you can have multiple ones, right? So you can have multiple applications that do different things, and the web server can handle all of them. So the web server will be able to just handle requests to any application. So you could have a rule that, for example, it will say, so you would have a rule that says, if I have a search, so if I have /search in my path, then I want to use search application. Right? If I have /auth, like authentication, then I want to use auth application, and so on. So these could be completely separate projects, but the web server will handle that based on the rules. So whatever rules you set up, it will kind of direct the request to the correct path. Now, you might see, well, hopefully you won't, but you might see some projects being set up without the web server. And that is pretty much what I'm going to show you today with Express.js. And basically what you can do, what Node anyway allows you to do, is to have kind of web server built in into your Node.js application. So you could get rid of this middle part, right? And you can have just your application. So you can literally just have, sorry, just do this. So you don't have this one, and this one would go directly in here. Oh, no, this one, sorry. This one will go directly in here, right? So you would have this. Okay. Anyway, so it could look like this. Now, the obvious problem in here is, you see this junction in here. There is nothing to be able to direct these into different applications. So the request to different applications. Now, going back to this example, the one thing that we didn't mention are ports. Whenever you make a request, HTTP request, it will go to port 80. So if you do google.com 80, something like this, this is how you write a port, and 80 is reserved port for HTTP communication, for web communication. Actually, this one will go to port 443 because this one is HTTPS. So there are different ports for different communication, but 443 and 80 are reserved for web communication. So in here, if you want, you can configure your application to listen to any incoming requests on port 80 or 443, or whatever port you want, and the client would actually could make a request directly to the application. If you want to have multiple applications on the same server, then you would have to use different ports. So this is the main web application. It would be on this port. Then you would have this one on port 3000, for example. You would have this one on port 6000, and that's pretty much it. So then, in that case, you would have to write the address like this, because by default, web browser doesn't know that there will be application on different port. It knows only 80 and 443. So if you write HTTPS, it will know that you want to translate this address into this, right? And if you write HTTP, it will know that you want to translate it into this. So that's just the default behavior by browser, so you don't have to write the ports. But if you have custom port, then you would have to write it in here. So that kind of, that's not very nice way to handle multiple applications on the same server, on the same domain anyway. You would probably want to have the web server in the middle that basically takes care of that, depending on much more robust rules, depending on what is actually in the request, right? Because then you can do a lot of different kind of magic with that. Also, the static files in here, these static files now would have to be connected to this one, right? Because the application itself would have to take care of serving the static files. Not the web server wouldn't do it for you, basically. So you're taking the whole web server out and you're putting it in here. And now these ones, let me just show you. So these ones, you can delete this one and this one, basically. So these ones are kind of floating around and you can't really connect them properly. So you took the web server and you put it in here. So that's pretty much what your Express.js is doing. But obviously your Express.js application can still live behind web server. So that's a good news. So you can still write Express application. It's just going to be behind web server. So there will be another hop, and then you can have multiple Express applications running at the same time. And they can be listening on different ports. Yeah, so that's pretty much it. Does it make sense what the web server and request and response are?
It will make more sense once we get into the coding and we can actually see it. Yeah, it's conceptually it makes sense, I think. Right?
So this
I think it needs, I guess, a bit of more practice and getting into it to really fully grasp it.
This thing that I'm showing you now is more about architecture than actual design of application, right? So this doesn't necessarily matter if this is Node.js or anything else. This is basically how architecture works for websites. So you will find that pretty much everywhere for websites. We will.
The web server is like a gate to the actual server application and the database.
Yeah, exactly. So the web server is your first gate. There will be more gates eventually if you go more into architectures. There are more gates. I don't want to confuse you too much with them right now, but web server is the one that will take HTTP requests and it will somehow handle them. So it will basically you defined where it goes. I will show you a example. Of configuration. Maybe it will be actually much easier to read that for you. So Nginx is one of the most used web servers, and this is a example configuration for web server, right? So when I say web server, it's an application. The application by itself doesn't do anything. The only thing that the application does, it will listen on some port, and that's it. But you need to give it a config to tell it what to do, right? So it's kind of like a, let's say, well, it's not dummy, but like without any input, without any config, it will not do anything basically. So this is your Nginx configuration. Just very quickly running through it. Don't worry about these for now. Let's do two events for now. You see in here we're saying HTTP communication, right? So I want to handle all the HTTP communication, and I want to say my index is either it will go like this, right? So it's either a index HTML if it exists. If it doesn't exist, it's a index HTML. If it doesn't exist, it will go to index PHP, which would be very likely your application. So this is, for example, this is very useful when you want to do like a maintenance page, right? So if you want to do maintenance page, you just put index HTML in there. You don't have to kind of delete your application. You just put index HTML, and you can serve your maintenance page in there, and it will not go through to index PHP because it will find it first. Don't worry about these. And then look, this is the actual configuration for domain, what I told you. So in here we're saying, okay, this is my one server. They call it server. Listen on port 80. That's your basic, that's your default web port, right? The server name. So you're saying this is I want to match these domain names. So this is the server name. I want to match these domain names. So whenever any request comes for one of these, handle it within this block with this configuration. Access log is just where you write some logs. Root, that's your root folder. So when I handle these, where does whatever is handling these requests live? And this one is living in HTML folder. And then it will say, well, if the location that you're requesting has a PHP in it, in this case it would be very likely the index PHP that we have in here, then take the request and pass it to this local application. This is the IP address that I was talking about before, 127.0.0.1. You will become to learn that very quickly. It's a local host. That means it's your local machine, right? So when you work on something on a computer, if you start your web server locally, you can write 127.0.0.1, and that's what you will see, that local web server. That's your local. And in this case, for PHP, there's a fastCGI kind of server that is serving on 1025 port. So basically what we're saying in here, take all the requests to this domain and pass it on to this, which is local application. And then that application will handle whatever it needs to do with the requests. Same in here, listen to 80, but these domain names, right? So both of them will listen for 80, but one is going to be domain 1, the other one is going to be domain 2. Serve the static files. So this is what I told you with the static files. Look, it will look at the location where it's actually going, and it will check, am I requesting folder images, JavaScript, or JS, CSS, or anything like that? Then this is where my static files live. This is basically location on your hard drive where the static files live, and expires 30 days. So this is saying use some kind of caching for these. And again, pass anything that's other than the static files into this local application, which could be Rails, Zope, or anything else, Node.js, anything else. So you're passing it into this port. And then this is example actually with which could be a Node.js, but this is more like a load balancing. I'm not gonna tell you that because that's too advanced. So this is basically how you configure your server. What you would expect is, what you can expect is if you have very sorry.
Sorry about that. That was just me. I'm getting a bit sick. Sorry.
So if you have very simple server with like 1 or 2 domains, you would see something like this. You would just say, listen on my port 80. These are the domains. This is where I want to save the logs because if something goes wrong, you want to know what went wrong. You will be serving your static files from the web server because most of the time you don't really need to go through the application to actually serve static files. And then you will say, okay, now take the requests and pass it on here. So this part with the location where you're passing in, that's basically this part, right? So you're saying web server, take the request and go here, or go here, or go here. Choose which application it goes depending on the rules. Okay. So that's the configuration for web server. That is really like a server kind of thing. Does it make sense?
Yep.
Yeah. Cool. So that's our request response. It's much, it's very simple. I would imagine if you thought it's complicated, it's not that complicated. These are the main things. But remember that the URL, I will show you again. If I inspect this page, look at the network. If you look at any request, you see it will show you as a request URL. But what it really is let's just go to this one. It doesn't show as a text in here, so it doesn't show as a text in here. So the part in here, it already parses it, but basically this request URL is what is in the headers as a host URL. So it tells you where to go basically. So in here they already, actually like me, they already split it out to just kind of make it as a standalone item, but it's not necessary. If you look at again what I told you about the translation of addresses, in your browser you're requesting this. So if I put this in my browser, I will see the image, right? Hopefully, you see. So I loaded the image. So this is my image. Now when you request this, it will take the address part of the URL, which is this. Oh, sorry, actually it's this, right? It will take that and it will translate it into an IP address, right? And you can see the translation in here, remote address. So images.unsplash.com, its actual IP address, which is the public network address, is this one. And you will see the port in here, and the port is 443 because it's HTTPS. If it will be HTTP, it will be 80. So you can see that already it translates it into some kind of address, because names don't mean much in networking. It's all addresses, right? It's every single public point any network point has an address, but there are public addresses and there are private addresses. But that's networking. You can learn about that later. Right. So that's kind of intro to what's happening on the background when you make requests. So let's go back to Express.js. Yes, Express.js is a framework to help you to handle the requests. So now, when we talk about Express.js, we are here, right? In the architecture, this is where we are. So we made a request from the web server passed it on to Express.js and to application, which is running Express.js, and that's where we're gonna handle it. for the sake of this course, I think this is the architecture we're gonna go with. We're gonna assume there is a web server in front of it, because it's always better to have a web server in front of it. It's also security kind of better for security. It makes handling requests easier, because obviously you're handling them in a kind of nice frameworky way rather than in plain JavaScript. And there are lots of libraries to support it. One thing really good about Express is middlewares, and we will touch on that. And there is millions of, well, thousands of libraries that will give you different middlewares to do different things. Right, APIs. Have you learned a lot about APIs yet?
Separately, yeah, but not I don't think in this class, no.
Okay, so what to know about APIs is basically it's just web addresses as you would normally have, but APIs, the kind of generic understanding is that it will provide you some data. It's not going to load you a web page. It will provide you some kind of data, right? So you will make a request, and it will provide you with blob of data, be it a JSON, it can be HTML snippet, it can be text, it can be an image, anything, right? REST it stands for representational state transfer, which means absolutely nothing to people, obviously, but it's basically a collection of rules how to design these APIs, right? So whenever somebody says I have a REST API, it doesn't mean that they use some kind of library or that they install a piece of software or something like that. It basically means that they, well, at least think that they designed the API in a RESTful way. The REST APIs, so the REST is one set of rules how to design APIs. On top of that, you can then use your what you already definitely touched on. When you create, update, and create, read, update, and destroy, which is the CRUD operations. I think it's somewhere here. Well, HTTP methods could be translated as a CRUD. So with the REST API, just to kind of give you a little bit of background on what it actually is, those rules. Let me just find, I have it somewhere in here. It's not that important, but basically, the most important one to understand, I would say the most important one is that when it was designed, it was designed by one guy, and basically what he was trying to achieve was to split the client from the server, right? So the main point is the client is independent from the server. So like you would normally have, and I think Ricardo will probably know this, like you would normally have in monolith applications when you have, usually PHP or Ruby or something like that. We call them monolith because they go from front end to the back end, right? And for different reasons as well. But anyway, from front end to the back end. The very common term that you will hear as well is MVC. It's called MVC pattern, or just MVC pattern. And MVC pattern is model view controller, right? So you have one application, and the application is using these three parts to actually render the website. Okay, this is out of scope for what we do now, but basically that's the kind of old way. Well, not old way. Sometimes it's good, but that's one way to write applications. That you have a backend that then renders a page, right? What the REST API is trying to do is that instead of rendering page, it will give you data, and the client itself will have that rendering capability. So you will request data from the server will return some data, but it will not tell you how to render itself. And on the front end, you will decide how to render that data or what should change. So you're kind of giving independence to the front end in that way. So in that way, the front end can be designed, and it can be designed for different platforms, and you can have multiple clients consuming the same APIs without actually having to worry about how it's rendered, right? So if you imagine that you have a website, you have a mobile application, you have a kiosk in the shop or something like that. All these, they can request the same APIs. They can make calls to the same APIs, return the same data. They can receive the same data, but it will be rendered in different way. So on mobile you're gonna have much smaller UI or something. On website it's gonna be all huge and stuff. The other thing about REST APIs is that they are, or at least should be, stateless. What does that mean is that between the requests you should not be keeping any state. So one request can be always completed individually. You don't need the other request to complete it or somehow influence it. Obviously the state then, where is it kept? Because you need state, right? The state is then kept in things like database or queues or redises and things like that. So you're kind of moving the state to different site, and every time you make a request, which we call a session, every time within that session you will kind of recreate the state, right? So if I make one request to the server, and the server will somehow process my request, it will create a bunch of data, it will send it back to me, and at that point it will just forget everything. And we will make another request to the server, and at that point it will say, I want to do something with what you just created in the previous one. But the application, the REST API, cannot actually go and check what was in the previous request, because it completely forgot about that request. You need to give it some kind of data to identify the previous request or the previous data. So, and then it can go recreate, let's say, the session, and then it will continue. So to give you an example, if you have a book application, right, and you want, like a library, and you want to create a new book, and then in the second request you want to assign an author to it. So in the first request you would make, let's say, post request, and you say, I want to create a book, right? This is the data for the book. The server would take it, the API would take it, create the book in the database, and it would give you back a response, and it would say, your book has been created, and the ID is 1. In the next request, you want to tell to the server, the book that you just created, I want to add an author to it, right? You can't just say the book you just created, I want to give author to it. You need to somehow identify that book, and that's why we have those IDs. So it would say, when you would make the request, you would say update book number 1, so update book ID 1 with this author. And on the backend, on your RESTful API, it would go into database, it would load that book all over again, even though it just created it, it would load it all over again, update it with the author, save it, and send you a response, yes, it was saved. Right? So there is no state between the requests. They should be completely separated. And yeah, and the other, there are 6 rules for the RESTful. I will send you a link if you want to read through it. They are not that important. They are not that. Where are you? Here. They are not that important for what you're doing right now. That's only when you really design REST API. The one thing I would say is, a lot of APIs will claim by default that they are RESTful. They are not always RESTful. It's just one of the terms that is very loosely used, and it depends on the design of developers. You can't actually, there's no test to pass or nothing that would block you from deploying API if it's not RESTful or something like that. It's just a set of rules to follow. Right, going forward, obviously you can use your HTTP method, so get, post, patch, delete. This is what I was saying with the CRUD things, and yeah, and then you have your HTTP methods and URLs, so you can control it that way. That's what we already talked about in the request. So you have your method, you have your URL, and so on. Yeah, you can have multiple. So you can see in here that you have get, two slash directories, and you have posts to slash directories. So you have the same URL with two different methods, right? You can have that as no problem. As you can see in our diagram, it would go to the web server, it will check, okay, I have some kind of address before this, and that address needs to go to application. It will just pass both get and post. It will just pass both to application. And in the application, you would have handler for get and you would have handler for post, and you would handle them differently, obviously. You can see it in here a little bit. So this is already how you start it. If you just ignore the bottom part for now, and you can see in here we create a new Express.js server, and we basically saying handle a get request to this URL, so which is slash, that's our root URL, and respond to it somehow. And in the same way, like we have this, we could say up.post, so handle post request to the same URL and handle it somehow. So you just set up your rules. In here you can see an example of how to start an Express.js server. So you will create your application. I will show you in a second how to do it. You will create your application and you will say listen. So that means listen on a port. This is your port number. And basically at that point, when you execute this, the Node.js application will reserve a network port on the network interface that you're working on, and it will be listening to any incoming connection, so any incoming requests on that port. So again, in this case, we did 3000, right? So imagine that this application in here will now open port 3000, right? So the web server, when you make a request to the web server will check its rules, and in the rules will be, if there is a request to path to this path with the domain name, then pass it on to this application. And the application is on localhost, so it will be 127.0.0.1.3000, because we know that we started in here in 3000. So you would pass it here to 3000, and then that request will get passed in here, and it would you would have it in your application in here basically. And then you just set up your rules how to what to listen for. And yeah. And any questions on REST APIs?
No, not for me, thank you.
Is it too much information?
Yeah, I guess it is, but it's like every new lesson, it's always a bit kind of overload of stuff, and then we read more, we do more exercise, and then it becomes clearer, I guess.
By the way, did you guys decide if you want to be? I mean, obviously you're doing JavaScript course, but are you all? Do you want to all be front-end developers, or do you want to be back-end developers? Any one of you?
I need to wait until the course is over so that I can hire Thomas.
Yeah, so
I've never done any backend. I mean, I guess so far we've done a lot of front end.
Yeah, I was away a few minutes, like 5 minutes or so. Did I miss anything?
No, well, you missed some stuff on REST APIs, but I'm sure you can watch it or read more about it.
Yeah, no, it was just just 5 minutes.
So yeah, I mean, why am I asking is because what I just talked about in here, if you are a anyway, if you are a web developer, you should know how these things work, right? Like you will definitely be asked. I mean, when I do hiring and I have like a juniors especially, because you can't expect from them to know everything. The one thing that I would ask them is how like what happens when you write google.com into browser, what happens then? So knowing your architecture like this, like that it goes to some kind of server and that issues it's a request and it issues a response and so on and so on. That should be known by all the web developers, I think. Now, for the front-enders, you don't need to know too much of what's happening in here, right? You just don't need to know that much of it. Anyway, as a juniors, you should not know that anyway. It's nice to have to be interested in it, but as a junior front enders, you should be more interested in CSS and stuff like that. So you should just know that client makes a request to the server, so just this as a whole entity, and the server responds somehow. These are important to you, definitely. As a backend developer, if any one of you wants to be a backend developer, then basically the whole thing is quite important to you. You don't care about what actually happens on the client. You just need to know that you're sending them some kind of data, but you definitely need to know how servers are handled and how the ports work and so on, right? So if you are a backend developer, I would pay more. If backend sounds like more interesting to you, I would pay more attention to this. If it doesn't, then it's fine to just know that you're making requests and you're getting responses, basically.
I mean, the whole thing is very interesting. I mean, I didn't really know about this port. It just feels like it's like kind of under the hood. It's actually old school, like with radio frequencies.
Yeah, it is. It is a little bit like that, and it's funny because these things are, and this is anyway, these things are not being taught that much, and they are kind of fundamentals of what we do, especially as a web developers. And at some point in your career, you will definitely touch both front end and back end and architecture as well. Like you're learning now JavaScript, but JavaScript can be like Express.js, that's already backend basically, and you can write command line applications with Node.js as well. I think we did that together actually. So you will touch these things, and to be able to be productive in that and to be successful in that, you kind of need to know how these things stick together, right? So ports, for example, are a very fundamental thing about network communication in general, right? So like, for example, one thing that should kind of jump up on you when I say that, when I told you in here that Node JS will open the 3000 port on the network interface, the one thing that like you need to think about already is I am opening a port on a network interface, which basically means that there will be some range of ports available. And if I try to open port that is already open by a different application, then there is a problem. And the problem actually will be if you try to open port that is already running on that network interface, this will actually fail, right? This application will just error out. It will tell you this port is already open, I can't open it. So there are definitely some fundamentals to know about how it all works to be kind of successful in this, because you just need to kind of dig more deeper into it. And it's on the client, on the backend as well. There is a perception usually that on the backend is more because you need to know how the servers work and everything, while on the front end, let's say, it's a little bit more like stylish and a little bit dummy or whatever. But actually, there are so many things to learn about how browsers work and how they render things and all this kind of stuff that backend has absolutely no idea about, right? So there is something on both sides. So you definitely
application. So what is so application is like Node.js? Okay, Node.js is type, but then are we saying it's an app that you create with a lot of program pages that does only search, for example?
Yeah. So application is basically, it is an application. Even our web application is basically a command line application that you create, and the only difference between just command line application and web application for Node.js is that you open the port. So basically you're saying I am now available in the network. That's the only difference, really.
Got it.
Yeah. So the application could be really anything. It depends. So what the application is and how many applications you have, it really depends on your architecture. And this is something that, like, hopefully, as a juniors, you're not gonna have to deal with at the beginning. So if you join a company and they don't have architect and you will be involved in doing this, then you will be involved in this other than just for exercise, just for your own good. if they actually will expect you to have like a meaningful input, then there is something wrong with the company. Like companies usually will have someone who is a good architect. They will either have a separate role just for architecture, or they will have someone who is senior enough, who is strong enough to actually do architecture, right? This kind of stuff takes a long time to get right, a really, really long time. You can design something very quickly, but kind of foresee how the architecture could work together well and stuff like that, it takes really long time. And then, as you mentioned at the beginning, you move into things like AWS, where you can basically set up all this, but now we're talking about server. So we're talking about one unit. But what actually happens on AWS is that all of these applications, each of them will have its own server, and each of them will have different set of rules, and they will be load balanced, and they will be they will be behind like Docker or something, and so they will be like spinning up and closing down all the time, and then you're gonna get Kubernetes in, and you're gonna have like an orchestrated architecture and things like that. It can get really, really complicated. So there is definitely, I would say, if somebody wants you to be involved in architecture, if somebody tells you be involved in architecture so you learn, perfect. If somebody tells you be involved in architecture because you need to make decisions, just run from that company. Like you are not in the position to make architecture because there are big consequences, and there are there are just things that really take years of practice to get down to be able to actually successfully do that.
What do you prefer?
Well, actually, I've been kind of jack of all trades, really. I started on the back end, then I moved into front end, then I moved into architecture, and now a couple of last years, I'm kind of going. I'm more doing of a team lead and architect kind of role, even though focused on the front end recently. But yeah. But I did quite a bit of architecture, and architecture is one of those things where you actually need to get accredited as well. So I have a couple of certificates and things like that. Like it's really complicated stuff, and you don't want to, as a junior, you don't want to get overwhelmed with that because it can get overwhelming very quickly.
Interesting. But I guess this is also, I'm thinking about the company I'm in. It's nothing to do with software. We're just an investment company. Our IT guys, I think what they do is it looks like they are outsourcing a lot.
Yeah.
So all of our stuff is like Microsoft built-in stuff.
Yeah, that happens a lot, and for a good reason, to be honest. Well, not always, but like most of the times for a good reason, because as I said, like there are people who just do this full time, right? Like, there are people who do these kind of diagrams and setting up architectures full time, and this is not something that for a small startup that doesn't expect too much traffic or whatever. Yeah, sure, you can knock something up together, but on your own, but. If you want something proper, then then you hire someone. And I was working for a fintech company where we did architectures for banks and stuff, and we were doing it really well. But still, like in some cases, we actually went and we found like a certified AWS company that actually does it like all the time, basically for huge customers. And we just got their input on some things because they can do it better, right? Like there's no, and this goes for the whole development. There is no shame in just admitting that somebody can do something better or that you don't know something, right? Like even me now, like if I show you some things, like Googling, I feel a little bit self-conscious, but to be honest, like not everybody can know everything, right? I definitely don't know everything. So
yeah,
it's better to just hire somebody who does, right? And also you kind of moving the liability to someone else, right? So if you...
My point was actually, it feels like my company is more like, it could be better, and it's all like we're using Microsoft stuff that could be...
yeah, if you're using Azure, it's it's funny because AWS was the biggest player. Now Azure is getting a lot of traction, and yeah, there's more and more kind of experts coming out in Azure. So it's not bad, but it really depends on how it's set up. Like architecture, yeah, it depends on how it's set up. It can go really wrong or really well as well.
Right.
Right, let's go back to Express for now. So I think that's it for the presentation. So
Express is a web server then?
Express is a framework how to handle requests, but you can do pretty much the same things like you can do in a web server with it. Right. The one difference between Node.js and possibly other languages is that Node.js actually has a built-in web server. If you don't forget about Express for now, but Node.js actually has a built-in web server, so you can start a web server from your Node.js application without actually having to install another web server application. Ricardo, correct me if I'm wrong. I think from a newer versions of PHP, they have built-in web server as well. I think there is a param that you can run your PHP scripts with you can just start web server in there. I'm not sure.
Yes, that is right.
Yeah. So you see, like other languages kind of catching up. They have their web server as well. When I was doing PHP a long time ago, there was no web server for PHP. And there are other languages like I think maybe I don't know, Python or Ruby or something. I don't really know. They probably don't have built-in web servers. So in Node you can actually start full-blown web server, but it's not advisable because to do that, then you need to in JavaScript, all the rules that I showed you in that config, you need to kind of set it up yourself, and it's not easy. It's really, really not easy. These web servers with the configs, they make it very easy for you to set it up, and it's very solid, right? Also, the web servers are, as I said, they are on a different network level, and they are optimized for speed. So web servers, and this goes down again, that they don't actually see the whole request; they just see the kind of shell around the request with the method and the headers and stuff. Because of that, they can process everything very, very extremely quickly, and that's why they don't run any logic, right? Because if you start giving developers kind of the freedom to use some logic, then you're basically giving them the opportunity to make it slow, right? If you don't give them any opportunity to do the logic, then you can't make it slow because it's just inherently fast. So that's another kind of bad point with having server in PHP or in Node.js or whatever, because you basically handling it yourself, right? And you just can't write better web server than Nginx is, for example. You just can't do it. Like, even if you try really hard, you just can't do it because Nginx has been written over decades and it has been optimized for God knows what, and you just can't do it. You can't do it better. So that's why you wouldn't use it. So back to your question, Express.js is a kind of framework on top of this built-in web server in Node.js. It just helps you, it just gives you a nicer API because, as you can see in here, like this app.get, for example, this you can't do in just pure Node.js. You can do it only because you have the Express.js. In a Node.js, you would have to do it in a much harder way.
Right.
One thing that Express.js can also do is that it will serve the static file. So again, you can say if there will be some kind of matcher before this, there will be some kind of matcher. So it will say if you have this extension on a file, then serve a static file from folder that's called public. In here, you can already see the app.use. That's the middleware that I told you. So that basically app.use means add this middleware to every request. So when every request comes in, it will run through some kind of logic. I will show you in a second. And yeah, and that's it for the presentation. So let's go to code quickly. I still have some time here. So let's see how it does. So install Express.js is easy like any other package. So you would do npm install Express. I think it's just Express. Yep, Express. And then in here, so that's already installed the package, and then in here we can create the application. So we would say app. Can you see it well, or should I zoom in more?
Yeah.
Yeah.
Go npm install.
npm install express.
And this is global then, or?
It's not going to be global. It's not going to be -g. It's just installs it in your node modules.
Ah, yeah, okay.
Yeah. So on the first line, we will create a new application. So we would be basically saying create a new Express application, which is the kind of server, let's say. And then we will say listen, give it some port. So let's say 3000. Well, actually, I'm not sure if something is running on my computer on 3000. So let's do 3500. Let's do 3500. And console log server listening on 3500. Actually, let me just put the port in here. Right, so this will create our application. Yeah, so now we will have Node.js, Express.js application. Let me just do. Is anybody using VS Code every day in their work or something?
No.
No. I wonder if I can somehow put my terminal on the right hand side so you can see it easier, but I don't know how to do that in here. No, that was not it. Right. Oh. No. No. Right, let me start again. Okay, this, yeah. Right, so now if I do node, do I have node 1? Yep. Right, so I started the server. Hopefully you can see this. And you can see that the server is now listening on 3500. Okay. What happens now if I open 3500? Let's see. So if I do my localhost 3500, you can see it will give me an error page and it will say I cannot get this URL because it doesn't exist right now. Okay? So this is already built into an Express, right? So the first thing you should notice, I actually got something, right? Like if you look at the page source, this is my page source, right? So I got error and cannot get slash. As a developer, if you interact with API or anything, and you call it like I did in here, and you get any response, then that means it's available, right? This is very important. So if you get something, even if it's this kind of error, that means that this address is available. And I will show you what it looks like if not. So if I go and I kill this, so I kill my server and I go a refresh, this is what you will see. So if I don't have the server running, you will see this site can't be reached, because this means it's basically not available, right? But if I start it again, even though it gives me an error, you already can see something that is a little bit more presentable than the default Chrome error. So even if you get error, then you know at least this is available, right? This is very kind of, when you're debugging things, this is a very important slight difference, right? Like if you get error that you cannot connect versus if you actually can connect, but you're getting different kind of error. So that's quite important to know. Let me actually start Postman. I think I showed you Postman before. Let me just create a new desktop in here, because we're doing API, so it will be easier to kind of test it in Postman. So if I come over and I can't take it up for some reason, there you go. Right, so so if I create new request and our address is localhost 3500, send, and you'll see that I will see basically the same thing, but in Postman. Okay. So now let's continue. Let's handle this request. So we know that this works because it's available, and we are available on 3500. So now we can start first request. So we will say upget. So in here we're saying we are handling get request. So method get. The slash, which is the root, let's say, and then the API. Again, you can read all this in the documentation, but and I like to say API, but basically the blueprint of this is you giving it a callback, and the callback will give you request object and response object. Okay, and then we will send some kind of response. So we'll say res, and I think it's called send hello world. And this is already our first API. Like you have your first API. When you request your slash, you will see hello world in the browser. So let's well in the response. So let's see if we send this. See, it responded with hello world. So this is already your API basically. So now there is literally limitless things that you can do with this, right? You can respond with some kind of object. You can, if I do foo bar, for example, and I request it again, you see I get foo bar. You can do anything you want with it. Now, one important thing in here, and this is why Express.js is a framework, right? Let's go back to this. So I am getting hello world, yeah. Now let's look at the headers. So these are my request headers, that's fine. These are my response headers. Look at the content type, right? Text HTML. So basically what it's saying is I'm sending back a plain text, let's say, yeah. So in our application, we set respond with hello world, respond with just this string. The Express.js took that instruction and kind of converted it internally and saying, okay, you're doing string, so I'm basically responding with HTML, well, with text. So this is what you see in here. Now, if I change it, you can see content type from the response, content type, text HTML. If I go back and I change it back to the object as it was.
Sorry, okay, it's because you say require Express. I was just wondering where we know we are in Express or we are kind of in an Express framework, but it's here. Okay.
Yeah. So the framework, it doesn't necessarily encapsulate the whole application. It's just a library that you bring in to your script.
Got it. And whenever you test it, you have to have no daemon on. I mean, it has to be kind of listening, because you're listening to a port. So it wouldn't work if you run the application.
Well, if you run the application, it will work.
You do like node.index.js.
Yeah, you can do that. If I do node.index.js, then it will listen as well. But I just use node1 because as I do changes, it will automatically restart.
Okay.
Because every time you do a change, you need to restart basically.
And do we need to configure or configure Postman as well then
the Postman, you don't need it. I'm just, it's kind of nice to use it. It gives you a lot of data.
I'm wondering if in our exercise we also need to do it, but maybe I'll see later.
I don't think you will be doing it in your exercise, but Postman is definitely one of the best tools for especially for front-enders when you're going to be trying different APIs and what they return and stuff like that. Rather than coding it, you can just use Postman. It's very useful. Yeah, so now we changed it into an object. So let's go back and make the request again. We will make it again. You can see that the response now looks a little bit different, right? It looks like an actual object. It has actually this line numbers and stuff. And if you look at the headers, content type is now application JSON. Right? So it will actually it's actually telling the browser, well, the client is actually telling the client, that the response brought back data which is in the type of JSON. So the client knows how to parse it properly, right? And that happened without us doing absolutely anything, right? Like before it was string, now it's an object. So this is why, and this is kind of like when you think about frameworks versus libraries and stuff, this is why this is a framework, because it does stuff for you, right? Like, so somewhere inside of the Express, when you do send response, it will check, whoa, so we are sending an object, then I will set automatically the content type of the response to application JSON. If I send just string, I will change it to something else, and so on, right? So it does it automatically. You could change it manually if you want. If you say we're sending this object, but actually we want it to be, I don't know how it's set header, and there will be content type, and we will say it's actually text HTML. So you can manually change it, the behavior of the framework. So now you see I'm sending back the same object, but now it looks very different, right? It's just a plain text. If you look at the headers, content type, text HTML. So we kind of change the behavior. So you can, even though it will do it for you, it's flexible enough for you to be able to do whatever you want with it, basically. Right? And this is quite nice from Express, but it's nice. It's good to know, like, why is it happening, right? Because otherwise it would be just magic. Like if you change string to an object and suddenly it changes the header as well, it's kind of like magic, and that's what you don't want in development. You want to understand why is it happening. Yeah. So actually, we can write it out even a little bit. So when Express creates the response, it would have something like if, and I'm just gonna write it as a pseudocode, but if body, it will have something like this type of body equals string, then the response set header content type is text HTML, for example, something like that. And it would have more ifs or switch statement or something like that to kind of set the header depending on what the actual response body is. Yeah. So that's what it does internally. But for you just can use it like this, and you don't have to worry about it. So that's nice, as long as you understand why is it happening. So that's our GET request. Now let's do a POST request as well. So if we do up POST, the same URL, so the same part of the request, and we have request response, and we will say res send. So we'll do hello from get, and then he will do hello from post. Yeah. So you see we're doing two handlers for the same path, and we are sending back different things. So let's see if that works. So I'm making get requested to our application, and you will get hello from get. If I change this to post, hello from post, right? So you can do different logic. So now, as you can see in here, you have all the freedom you want to put any kind of logic. Like there is no restriction on what you can do inside of here. This is just a block of code. You can do whatever you want. You can connect to database. You can call to another API or something. You can do absolutely anything you want. Yes. Yeah.
To kind of link it to what we were doing on the front end, when we were using a fetch, or sorry, a fetch method with a get or a post, that would be what's happening on the front end, and then what we're doing here. That's how does it actually change? How do we link it to what we were doing before? Like this.
Yeah. So
promises and
the way to think about it is what you're doing on the front end is the one that is the requester, is the one when you actually create the request, right? And in here is the receiver. This is when you receive it, right? So on the front end, you would do something like fetch localhost 3500, and do something, whatever, something like that. Or actually, sorry, not this. Then so this is when you're making the request, while this is when you're handling the request. So this basically goes from here up to here, and this will handle it the same way.
Line 16 will be what is in the REQ parameter, or
so the sorry, I should show that as well. So the request, so REQ is request, RES is response. Again, you can call it request response, right? It's just parameters, you can do whatever you want with it. So the request is what you see in here, right? So this thing, this is the request object. You initiate that from the front end, and it will have all these values in it, plus a lot of other values. I can show you what the request looks like. Look, console log request is the best thing you can do. Just console log something.
It's like a big object with lots of stuff.
Yeah, and then we're gonna make a request to get, and look at that. All this stuff is in the request. Actually, we can probably, let's see if we can actually return it as a, I'm not sure if that's gonna work, but let's try. No, it's converting the circle list, actually, you can't do it. Anyway, yeah, so this is
you do whatever you want to do in this get. That's basically, you take the request and trim it down to what you are interested in.
Yeah.
And kind of do something like return something somewhere else.
Exactly.
Okay, got it. Understood.
So let's just do. I'm not sure if this is actually this new version of Express is supporting this, but let's try this. I'm not sure if this is gonna work, but let's try it. Oh, I didn't want to do that. Right, so now if I send this, what is it? Okay, good. And if I do hello world, right. So now look, I created a new path in here, and actually let's add some query parameters in there as well. So I'll say foo equals bar, right? So I'm making requests to this. So /hello/world, and the params are foobar. Now I created a new handler, which is star, which basically means match everything. Yeah, so match any kind of URL. And if you look at the request, I'll show you if I scroll all the way up to the request. There's lots of stuff in it. Come on, where is it?
Wow.
That's a lot of stuff.
Feels like there's stuff in double.
Yeah, there might be some actually doubled. Oh, here, that's what I was looking for. So look, like when you have your request, it will show you what the original URL is. It will show you the parsed URL, so it will tell you what is the path, what is the href, what are the params. It will show you as well. And then somewhere here should be the search params as well, which will be the foobar. If I can find it somewhere, let's see here. Yeah, so it will give you all this kind of data. Like all these things that you see is very low level stuff about the actual connection, right? About the actual connection of the request. So this is basically what the web server would see as well. But when you receive it in the node, it will automatically unpack the oh, there you go, query, look, foobar. It will automatically unpack the request and parse the body of it and stuff like that. So you can then have this kind of nice API. So this is already request as Express.js parsed it basically. And if you go to Express.js documentation, if you just search for Express request, so here you have request, and in here it will tell you all the properties, right? So properties of the request, and in here you can just scroll through them, and it will show you exactly what each property means and how to use it, and so on. If it's fresh, if it's what is the host name, that's the actual host name that I was talking about before. What is the IP? That's a new addition. I didn't see that before. It's pretty cool. And all sorts of stuff like this. Loads, right? And the same for response. It will show you a lot of stuff about response as well. How you can use it, and methods. So you can append something, you can attach file, you can set cookie, and so on and so on. You can do absolutely anything you want with this. So it's a full-blown server basically. Let me show you. Is that okay? Yeah.
Yeah, I'm amazed. It's nice.
Yeah, this is really. I mean, backend can be really exciting. So there is a lot of stuff to do. Yeah, that's why. Just check out if you want to be a backend developer as well. The one thing that I want to show you before we go, do I have some time? Actually, I have 15 minutes. I will do that. So the middlewares, right? So the middlewares are the kind of heavy lifting in Express.js, let's say. What that means is, if you have things that should happen for every single request, then you can use it as a middleware. The syntax is upuse, so that basically is saying use this middleware, and then you will just say, okay, here's my request response and next. At least I think this is the syntax. And in here you can do anything you want with the request response, and then it will be passed down to your get. Okay, so to your handlers. So now I can say for every request I will do console log request base URL, for example, and then move to next. So this next is basically move to next inline, which could be middleware or just like continue down to the get. So now I should see, is it still running? Yeah. I should see that if I make this request, it will be fine, right? Hello from get. And I should see in here the log somewhere. So let me just can I clear this somehow?
Can you repeat the function of the use in there?
So the use is a middleware that you can use in the application. So basically, if you have some work to be done before every request, then you can use it in the middleware rather than actually writing it into every single handler. Actually,
so that means that the use is going to be running for every single request that the site gets?
Yes.
What if I want it to run not for every single request but selective one?
Yeah, so you can scope the middlewares as well. Express does it as well. So you can do like a groups of requests that use different middlewares, or just inside of your middleware, you can decide, right? So inside of your middleware, you can say if the request is to this URL, then I want to run it. If not, then just move to the next one, and so on. So you can skip stuff as well.
What is a good example of using the use? Why would you use a middleware?
Good example good example would be authentication, right? That would be one that is really good. So you can say I'm getting my requests, and unless actually let's do that. So you could say if
Don't you use the sessions to validate if you are already authenticated?
you can use session, but you need to get the session from somewhere, right? So you need to get it. Still, you can need to get it from here. So in the middleware, you would get the session ID, then you would load the session from database, and then you would check if you actually are if it's correct, basically, if it's valid session.
Okay, I'm going to ask, making a reference to PHP, but basically, whenever I'm going to be dealing with a page that needs to validate if the user is authenticated, I just put as the first statement in that page a session start function, and that will actually take care of, like making sure that if you are not authenticated, you're not gonna get access to that page. Don't you use something like that in here?
Well, you can't do that in RESTful API, no. You can do it. You can do it in if you actually serving the pages and stuff. If you making
okay. Well, yes.
Yeah, because this is not, you can't do, you can do RESTful APIs with this, but you can't do like a full-blown application. So like in PHP, you use sessions, you use the kind of built-in sessions because you're actually doing the whole round trip on every re-render. Then yes, you can use it, but in here, because it's a RESTful API, you can't use it.
Now, just to know what it's coming during the course, what you're going to be teaching, whenever are we going to be doing any sort of MVC where eventually we will send the routes or the request to a specific view, or that is not used here, and basically we just render the pages from the callbacks functions in the routing?
I am not sure. You will have to ask that Vasil.
Okay.
Because he knows better what the plan for the next sessions are.
Okay.
I don't know, unfortunately, no. So I just want to show you some kind of diagrams, because I think they will be easier to understand than me explaining it. So some good Express.js middleware. So yeah, let's have a look at this one, for example. So you see, you make a HTTP request, you match some kind of route, and then you go through the middleware. So basically, the request arrives to the Express application, as you can see in here, and it goes through one middleware, second middleware, third middleware, which could be authentication, for example. Then it goes down to the main task, which let's say is this one, right? That's your main task for the get, and then it will issue the response and go back to the user. So basically, middleware is almost like, if you imagine adding steps in front of every single request. Yeah. And very useful stuff for logging, for authentication, but you can do literally almost anything. CSRF, I'm pretty sure that Ricardo knows as well from PHP. You can do all these kind of things in Express with middlewares, basically.
What's the goal of it? Like, wouldn't you be able to put functions in your main task? Like, for example, in this example, you have like a course, a CSRF, and authentication, and have some, I don't know, like if-else type, like it kind of opens it or not, depending on where you're coming from. I don't know.
Yeah, you can do that. So if you create, look, I'm gonna create 5 paths in here. So let's say this is my root, this is my books, this is my books 1, and this is my books 1 authors or whatever, something like that. So I have my paths in here. So if we don't use middleware, we can say okay, this is like a example of authentication. Let's say I will take my authentication and I will put it in here. I'll put it in here. I'll put it in here. I'll put it in here, and so on. Right. So you can do something like this. You can.
It gets messy.
But then obviously lots of repetition. So if for example I want to change this value, then I have to change it everywhere. So middlewares are very good for not repeating yourself basically. And you can chain them as well, so they can depend on each other. So you can say I want to have one middleware and then the next one. You can chain them inside in here as far as I remember as well. So if I would do let's do const of middleware, and I haven't done Express for a while, so let me just see if this works because I'm not 100% sure if it's gonna work. What am I doing here? Cool. So now, yeah. So you see, I have added the middleware just to this GET request. So I have my middleware split out. This is what Ricardo was asking about as well. I have my middleware as a function, and I can just apply it to whatever I want. So I'm applying it to my GET request, right? So I'm saying this is the syntax for Express. I'm saying this is my URL that I want to handle. My first step is this middleware, and the second step is my request response.
Okay, it's a lot cleaner.
Yeah. So this could be many of them could be in here like this. So now, if I go here and I will say, this is my bar authentication, and I would say, if I only remembered what it was. I think it was something like that. Actually, I could just do it here. So now it's not. Yeah. Let me just Google this quickly because I forgot how to write it. So is it just the next then? Oh no, it's the first one is the error, sorry. Yeah, the first one is the error. Okay. Alright, so if I send up this, then I get actually. Okay, so now this works now. Right, so if I received my error from here, so now I have my authentication middleware, and the authentication middleware will check if the request has a header with this name. Then if it doesn't have it, sorry, if it doesn't have it, then it will return error. So next bot authentication, if you put something in the next, that means you have an error. If you don't put anything in there, that means you don't have an error. So I'm saying if I don't have the header, say bot authentication. So now I can say if I have an error, then do res status. There was something like status, but let's see. So let's do send. I just do actually listen the error. Else listen this. Not 100% sure how to set the status code now. Oh, there you go. Yeah, so now you can see, so the middleware itself gave me an error that this is not authenticated request, and the error from the middleware was passed into the actual handler of this task, let's say, and in here we are checking if we have error, then send a 403, which means you are not authenticated basically, or you are not allowed to be here. Or we can put it 401. Let's do 401. And the error, and if this passes, which means if we have this header, then just say hello world. So now if I send this, I will get 401. You can see it in here. I don't know if you can see it because it's really tiny, but you can see status 401, and it says bot authentication. If I now go to my request headers,
and that you choose the 401, or there is some norm, like talking about like radio, kind of talkie-walkie. Like, is it like, okay, if I'm doing something that's unauthorized, it should be 401?
Yes,
like,
yes. So
driving list, like a
exactly, yeah. So there are HTTP status codes are kind of set in stone. Basically, what you should be using. You can code it the way that it uses completely different codes, but then your API is not gonna make any sense to anyone. So it's better to kind of adhere to it. So yeah, definitely, if you want to read up on HTTP status codes, because there is not that many, and you will know what. Yeah. So now, if I add the header, I should be getting 200 now, and I'm not. I don't know if I refreshed it. Oh, because it's lowercase. Sorry. Right. So now this.
Here, created 404 automatically or not?
Why am I doing 404? Is it because of this? Or maybe it's because of maybe I need to do next in here. I'll just do next in here. And then in here we'll do request response. Maybe. Yeah, so now I'm getting hello world. So now if I have this header in here, I will get 200. If I don't have it in there, I will get 401 unauthorized because I have bad authentication. So we basically created now authenticated API where you need to know where you have to have this header. You can also make it even more secure. I mean, this is just an example, but you can make it more secure. You can say the header needs to equal coders in hoods, right? So now again, if I send this even with my header, but that says hello, the value of the header is hello, I will still get arf. That didn't work. It should work.
Is it because you put or?
Ah, yes. Thank you. Yeah. So no. No, there should be or. It's just not. There was not equal coordinates. Yeah. Okay. So now if I send the header and the value is hello, then I will get 401. So I still send the header. If I change it to coders in hoods and send it, I will get 200. Right. So this is like a secret basically, and that's exactly how the APIs work with these kind of authentications. Cool. Any questions? I'm sorry I'm already going over time, but any questions?
Yeah, I guess it's a topic for later, but I was just curious as to how it works when you generate like passcodes and authentication, like where it's actually coming in.
Yeah, that's really a really broad topic, because there are different ways to approach it. There are different norms as well. There is like OAuth and other things, JWT and things like that. So yeah, that's definitely a broader topic. But we could do like a simple exercise at some point.
Okay, I got a few questions,
Sure.
including the fact that I pasted the project in Slack. Hopefully, at least we can read it. But before going there, let me come back to the code that you have in there.
Yeah.
And try to understand what you got in there. Basically, the line 4, it's defining a function called auth middleware.
Yeah.
Which takes as parameters the requested response and the next. The next, basically, what it's going to be doing is that it's going to call something else, like in a chain of things.
Yeah, exactly. Next in chain, yeah.
But then when we call the line 12, we are calling the get method from app, and we are routing from root to take that to the authentication middleware.
Mm-hmm.
And then what else is doing line 12? I mean, seems like I'm calling a function again there in the parentheses with request, response, and next, and sending inside the function. I'm actually just checking if I have an error or not. So it's kind of confusing seeing everything.
Yeah, so this is basically another middleware. This is just handling an error. So if error came at any point during this whole chain, then this will catch it and process it.
Okay, this is way more readable.
Yeah. And then, so the way that Express works, it will go through all the middlewares that have this kind of syntax with the next, right? And then it will arrive to the last one, which doesn't have the next because it's the last one, and it will execute that one if it gets all the way there.
Okay. Now it's making sense.
Mm-hmm.
Do we actually manually build every route in the index.js file? Or once the application grows, we order it in different files? I mean, generally, in any other framework, you will have thinking about framework, you will have like a route file, for example.
Yeah.
I'm assuming that will be the same in here?
You could, yeah, but this is basically how you define them. You would define, as you know from routes file, you might have something like this, right? So you would have like books, and then you would do ID, something like that, right? You can do that in here. You can do that in here as well. So you do define the routes like this, basically.
So the right way to do it in Node is having them all in the index.js.
Yeah, I would say yeah, because what you normally do is you would have this kind of, let's say this is our blueprint of the API, right? So you would have that in one file, maybe not index, but in some file, and you would import all these tasks that you do in here. You would import it from somewhere else, let's say. And so all these basically handlers, you would import them from elsewhere, and you would put them in here. Because if you wanted to define the path somewhere else, you would have to actually export it. So you would have to do export up and then use it somewhere else, right? So yeah, it's not, I probably wouldn't do that necessarily. Usually what happens is that you would have another file which could be like what's going on in here? You would have another file which would say like books handler or something like that, whatever it is, books controller. I think from PHP controller is probably more useful. And then you could just say, this const handle books, for example, and here you go, and then you would just import it from there. So you would just say handle books like this. So you would import stuff into here, just not to have any logic in here. You would literally, the only logic would be defining the routes and the middlewares to it, and then all the logic would be somewhere else in other files. So normally in a normal, let's say in a usual project, this would be probably called server or something like that, and then you would be importing those in there, and then you would have your index where you would initialize this server and basically kick off all the work and stuff.
Okay.
Okay. Any other questions? No? I can have a look at the this thing quickly. What did you want to talk about in here?
Yeah, if you see the instructions, go a little bit up. Okay, yes, Lookup Trader. Create an application, you need to create the endpoints. So we have not seen any of the endpoints here yet, right? How do we create the user schema? I mean, all this is not something we've covered already, right? I mean, we have to wait until we get there, I guess.
To me, it's Chinese, so
Yeah,
we haven't seen it yet.
Yeah, I mean, it seems like
I'm sure that I was not missing anything. So yeah, we need to, I guess, eventually. So we cannot start working on that yet. We will need a few more classes, I guess, to get into working on the schemas and stuff. Okay, that's fine. Maybe I'm going ahead of things now. I don't want to push you.
Yeah, I mean, you can, like you could potentially take what we learned today with the Express. So creating, where is it? Creating the, creating the routes like this. You can basically start with that, and the user schema. Don't get too worried about the word schema. Is basically you can just do object, right? So this is basically user object. Each user object should have ID, first name, last name, balance, and that's pretty much it. So you would just, in your application, you would be handling the users, and you could just say like const user equals first name something, last name something, and so on. So you could create your user like this, and then if you want to actually create an API that would retrieve those users or something like that, then you would obviously have this somewhere globally. You could have like your in-memory database or something like that, and you could basically store it there. So when I say in-memory database, I mean literally just having an object in here. So you will have users, and that would be your object or your array of users, right? And then inside of the users, this would be renamed to something like the user. And in here, you could just say users push, and you would add new user. So you would say first name Thomas, last name Dostal, for example, something like this. So then when you actually handle it, so you would handle it on your get, and you would push into the users. So you would basically save the information. So on the next request, you could retrieve that information. when I say in-memory database, that means once you actually restart your server, all the data from users will be gone, right? It's just in memory for that particular run of the application. If you want to actually save it more permanently, you could save it in the file, like without actually installing databases. You could save it in the file, for example. So you could potentially start on this, but it is, it's not easy to do this kind of stuff, especially at the beginning. So yeah, maybe
we already have quite a few exercises already. I don't know.
Yeah, I assume. Let me just check. Yeah, I mean, your next session will be on databases, and then the next one will be document-oriented databases, and then there will be authentication, server-side rendering, and stuff like that. So you're definitely gonna touch more on schemas later.
Yeah, definitely. Then I was going ahead of myself, so we'll just wait until the time is right.
Yeah. Well, always confirm it with Wassel, but I would say probably yes. Yeah.
Have you started the exercises, Ricardo? I mean, for you, it's gonna be a piece of cake, but
I read what the exercise were about, and I decided that I better work on my real day stuff, and I was going to get hands on the project. That is when I realized that we might be missing information. So yeah, I know how to deal with the file systems and that. So
yeah, for you it's easy. Yeah.
I'll send you this just so you have it. All right, if there are no other questions, I will let you go.
Thank you, Thomas.
Thank you very much for listening, and I will see you next time.
Yeah, thank you so much. Bye, everyone.
Bye.
Bye, everyone. See you.